Hello everyone. I am Dr. Chander Pawar, working as an associate professor in the Department of Chemistry, Marri Laxman Reddy Institute of Technology and Management, Hyderabad, Dundigal. And during last class, we have discussed about engineering materials. That is the fifth module for the BTech system. And deeply, we were discussing about engineering material. What are the what is the classification of engineering materials? What are the types of engineering materials? And in that specifically, we were talking about the cement, classification of cement, and followed by the composition and properties of Portland cement. So now a little bit deeper about the how cement is working as a binder material, or how cement is widely used for the construction of buildings and bridges, etc. So now let us see here. There are majorly, when we talk about cement and its binding property, or cohesive property, or its concrete formation, there are several reactions. We call them as a setting and hardening reactions of cement. So basically, we all know that, we all see, with our naked eye, day to day life, here and there, buildings, construction, these that constructions. So basically, cement mixed with sand, gravel, somewhere 20 gravel and water, and that paste will be allowed for the setting. Setting is nothing but hardening. Immediately it won't be that mass, or that paste won't be hard. So initially it will be slurry type, little liquidous. So once we have give allot some time, 3 to 4 hours, it will be becoming hard. That hardening of cement is nothing but called as setting, or setting time. So now here we can see setting and hardening of Portland cement. Yes, we have gone very briefly about what Portland cement is, what is its composition, etc. in the last class. Now let us see how Portland cement is becoming hardening, hard. So basically, before that, cement is mixed with water to produce plastic mass. Plastic mass is nothing but which is semi-viscous, or liquidous mass. Okay, and cement paste, or cement paste, which slowly loses its plasticity. Yeah, plasticity, and becomes stiff, and ultimately rocky mass is obtained. This process is known as setting. Setting is nothing but hardening of cement. So as I said while ago, so initially what we are doing, cement is mixed with sand, gravel and water. So mass, plastic mass, slurry type of kind of thing is formed, and that will be allowed to set, or become hard. That hardening time is nothing but we are calling as setting time. Okay, now hardening of cement. Hydrated insoluble precipitate gel crystals have the ability to surround sand, crushed stones, or nothing but gravel, bind very strongly. This process is called hardening. Yes, very simple. Mixture of cement, water, gravel, sand. So what will happen? It will lead to plastic mass formation, which will ultimately become hard concrete. Now, the miller we all knows that, wherever there is a building, or anything, bridge construction, there will be a miller, which we put cement, water, gravel, everything into that, and it will make a paste, and that paste will be pumped for the concrete purpose. Now, miller or mixture of cement, sand, water, gravel is to develop strength due to crystallization, which is known as hardening. So crystallization, we all know that. What is crystallization? Crystallization is something related to hard material. Okay, amorphous is something related to loose, or random arrangement of atoms, or molecules. So crystalline materials means very much compacted, or that atoms are arranged in a particular fashion. So crystalline material, amorphous material. So here what is it is telling? Crystallization process. Upon cement, upon mixing with water, gravel and sand, what kind of reaction is taking place? crystallization is taking place. That crystallization is nothing but becoming hard, and that process is called as hardening or setting. Now let us see. Initial setting, there is a term called initial setting. Initial setting is nothing but how fastly or how quickly your cement is becoming hard. That is nothing but initial set. You have mixed cement, water, sand, gravel together, and how fastly, how quickly it is becoming hard, or setting time, how much time it is taking to become hard concrete. That is nothing but initial set. When cement mixed with water, the paste becomes quite rigid within a short time, which is known as initial set. Okay, yes, very clear. Now, this is due to hydration of tricalcium aluminate. Yeah, very important. Crystallization or initial set is happening. Why? Due to hydration. Hydration followed by the chemical. What is that chemical? Tricalcium aluminate, C3A. C stands for tricalcium, C3 stands for tricalcium, A stands for aluminate. So shortly we can write it as C3A. C3A is nothing but what? Tricalcium aluminate. Okay, what is that? That is the chemical composition which is present in the cement powder. Okay, now there are several reactions to understand this setting time. So first reaction is, we can see here, 3CaO Al2O3 with 6 hexa molecules, aqua molecules, sorry, 6 aqua molecules, that is water molecules, forming tricalcium aluminate. Here we can see. And how much energy is released during this reaction? 880 kilojoules per kg energy. Yes, it's a energy release means endothermic reaction or exothermic reaction. That's, there will be a general question that energy release, it means it is a exothermic reaction. Exothermic reaction means energy release or heat release. And when we talk about endothermic, heat absorbing or energy absorbing. Rather than that, here energy is released. How much energy? 880 kilojoules per kg energy is released. That means it is a exothermic reaction. Heat is released. Yes, when we mix water to the cement, what will happen? It will give a hissing noise. That hissing noise is nothing but energy release. And how much energy? This much of energy is released during this tricalcium aluminate formation. That is the first reaction. Now let us see another reaction. Yeah, here we can see day 1. What is the reaction? Same as we discussed earlier. Tricalcium aluminate with hexa aqua and 6 moles of water molecule combines, and what it is giving? Hydrated tricalcium aluminate, which is crystalline. Crystalline is nothing but it is becoming hard. Concrete formation is taking place. You can see here 3CaO Al2O3 6H2O. Tricalcium aluminate with the help of water. How much water? 6 moles of water. It is converted into hydrated tricalcium aluminate concrete, followed by the release of this much of energy, 880 kilojoules per kg energy is released. Why? Because it is exothermic reaction. So first reaction is clear. Now there is another reaction, and this reaction can be denoted as C3A 6H2O. C3, as I said while ago, C3 stands for tricalcium, A stands for aluminate. C3 for the tricalcium and A for the aluminate. Okay, C3A short form. If someone is not able to remember these formulas, 3CaO Al2O3 plus 6H2O. So if they are not able to remember this formula, they can simply write C3A plus H2O. That's also considerable. Okay, and this is further C3A with added or combined 6 water molecules. It is forming hydrated tricalcium aluminate concrete or crystalline material. Okay, now there is another reaction, that is adding of gypsum to avoid early setting. tricalcium aluminate has been added with gypsum. What is the formula of gypsum? Calcium sulfate, CaSO4, calcium Ca and sulfur and 4 moles of oxygen. So, calcium sulfate is nothing but gypsum. Okay. So, now this gypsum we are adding to the first reaction whenever we are performing the exothermic reaction, first reaction, we are adding gypsum. Why we are adding gypsum? To avoid early setting. Early setting means faster or very quick hardening or concrete formation. Why? Because if it is very quickly becoming hard or concrete formation is taking place, then we may not use the cement properly for slabs and construction of walls, bridges. So there should be some prolonged time interval, at least 2 to 3 hours. With that, it can be molded based on the desired construction. Otherwise, if it is fastly becoming hard, then we cannot use it and we cannot control its hardening time. So now calcium sulfate gypsum we are adding to avoid the initial setting. Initial setting is nothing but how fastly it is becoming hard. So we are controlling the hardness of cement by addition of gypsum. Gypsum is nothing but calcium sulfate. Okay. Now, and here what is formed? Tricalcium aluminate added with gypsum and water molecule. What is formed? Calcium sulfoaluminate, C3A, 3CaSO4 and 2 hydrated molecules, 2 aqua molecules. So that is nothing but calcium sulfoaluminate. Sulfo, why we are calling? Sulfur related. From where sulfur has come? From the calcium sulfate gypsum. Okay. So this is the function of gypsum to avoid the early setting or faster setting of the cement. Setting is nothing but hardening of cement. Now let us see, there is another reaction. So instead of tricalcium, here tetracalcium. How many calcium oxides are there here? 4. So tetracalcium aluminoferrite. So formula of this is 4 CaO Al2O3 Fu2O3. How much water molecule? 7 H2O. What is this? C3AF. Okay, sorry, C4AF. What is C4? Tetracalcium. What is A? Alumino. What is F? Ferrite. Why ferrite? Why? Because Fu2O3 is present. Why alumino? Alumina is there, that is nothing but Al2O3. And tetracalcium, we can see here lime. Calcium oxide is nothing but lime. So C4 tetracalcium. A stands for alumino and F stands for ferrite. And the formula is 4 CaO Al2O3 Fu2O3. And in first reaction, how many aqua molecules were there? 6 aqua molecules, 6 water molecules. Here instead of 6, how many water molecules? 7 water molecules. Okay. So tetracalcium aluminoferrite with the combination of 7 moles or 7 molecules of water gives rise to tricalcium aluminate, C3A. That is nothing but hydrated tricalcium crystalline material. And what are the byproducts in this? Calcium oxide with iron oxide and water. And how much energy is released in this? 420 kilojoules per kg. Okay, little lesser than the half than the earlier reaction. In first reaction, it was 880 kilojoules per kg. Okay, now it is more or less half to that. So in this reaction, 420 kilojoules per kg energy is released. That means it is also a exothermic reaction, which is nothing but energy release or heat release reaction. Okay, and If someone is having difficulty to remember this formula, little complicated formula, they can write this reaction, C4AF plus 7H2O gives rise to C3A tricalcium aluminate, C3A and 6H2O. Same product, setting product, hardening product, crystalline material. Only thing is that tetra calcium oxide with alumina and ferrite, and here instead of 6 molecules of water we have taken 7 molecules of water, and product is same in both the cases, in earlier reaction and here. Okay, now let us see into another. Here we can see day 2 to 7, basically what we will do when we construct a wall or any concrete, we will do the curing. Curing is nothing but applying water every day, twice or thrice, morning, evening, generally people used to do. So while doing this water, applying this water, what will happen? That is called as curing. That curing is nothing but, so whatever the crystalline material is, unformed crystalline material is there, with the help of water it will be becoming hard. That is the purpose to do the curing for the cemented wall or cemented concrete materials. So when we add the water, so it will become harder and hard. So here day 2 to 7, what is happening? Tricalcium oxide with the help of silica. Silica is nothing but sand. Initially we added cement plus water plus sand plus gravel, right? Yes, that sand is nothing but silica. What is that formula? SiO2. Silicon dioxide is nothing but sand, okay, which is widely used for the semiconductor preparations, okay, in electronics. So day 2 to 7, what is happening? Whatever the lime cement is there in our constructed wall or bridge, with the help of included sand and added water, it is forming tubermonite. Tubermonite is nothing but calcium oxide and silica with how many molecules of water? 3 molecules. And what is the byproduct? Calcium hydroxide is the byproduct. And how much energy is released? 500 kilojoules per kg energy is released. Again, this is also a exothermic reaction, heat release. When we do the curing to the wall or any cemented material, so it will fastly absorbs water. It is absorbing water means what? The energy is releasing. How much energy is releasing during this reaction? 500 kilojoules per kg energy is released. Now, this tricalcium silicate can be written as C3S. C3S. C3 same in all the cases. What is C3? Tricalcium. In initial reaction, first reaction, C3A was there. C3A. Tricalcium aluminate. In second reaction, C4AF. C4 tetracalcium. Here it is tricalcium. Here it is tetracalcium. That is nothing but lime, CaO. A stands for alumina in both the cases, first reaction and second reaction. But that F is something new to the second reaction. What is that F? Ferrite, Fe2O3. This, the grey color to the cement is due to this one only, Fe2O3. Okay. Now, in this third reaction, what is there extra? Instead of tricalcium, sulfur S is there. This S is nothing but SiO2, that is silicon, silica or silicon dioxide. Silicon dioxide. Okay. This is nothing but sand. What is that? Sand. Okay, silicon dioxide is sand. So tricalcium is nothing but calcium oxide, lime. Okay, mix, combination with water, sand, gravel, especially here with silica. It is forming the tubermonite. Tubermonite is nothing but calcium oxide, silica with 3 hydrated molecules. And then there will be a crystalline byproduct, calcium hydroxide, and energy is released. This reaction can be represented as C3S, tricalcium silicate. It is here. With how many molecules of water? Hexa aqua. Same as it is in the first reaction. Okay, hexa aqua, it is giving the tubermonite, that is C3S, and 3 moles of water followed by the crystalline material calcium hydroxide formation. So if someone is having difficulty to remember this complicated reaction, they can simply write this one. Okay, both are acceptable, either this one or this one, both are okay. Okay, now here we can see sequence of changes during setting and hardening in the Portland cement. Day 1, cement followed by the water paste and hydration of C3A tricalcium alumina with tetracalcium ferrite, tetracalcium aluminoferrite, this one. And it is 7th day, where it is leading? It is leading to gelation, that is nothing but C3. Yes, C3 is nothing but tricalcium silicate. And 28th day, gelation of this dicalcium silicate and tricalcium silicate takes place. That means finally the wall or bridge or in any concrete has been become hard. Okay. Now we can see here gypsum function of gypsum. What is gypsum? Calcium sulfate is nothing but gypsum, GYPSUM. Okay, calcium sulfate, here it is written. Where is that? Here we can see calcium sulfate is gypsum. What it is doing? Tricalcium aluminate combines with water very rapidly with the evolution of large amount of heat. Evolution is nothing but release of heat. As I said, it's a exothermic reaction. So tricalcium aluminate with hexa aqua, it is leading to the setting, that is tricalcium aluminate with hexa aqua crystalline material followed by the heat release. This has been added with gypsum, that is nothing but calcium sulfate, to avoid the quicker or faster setting time of cement. Okay, here we can see the above reaction shows how gypsum retards the early initial set of the cement. Retardant property is nothing but which avoids faster setting of cement or faster or quicker hardening of the cement. Okay, that is the gypsum function. Now let us see here. The cement is classified into 3 types: high alumina cement, waterproof cement, white cement. 3 types. So here PC stands for Portland cement. What is this PC? Not personal computer. PC stands for Portland cement. So different from the Portland cement, characterized by its dark color, high heat of hydration and resistant to chemical attack. Initial setting time of 4 hours and final setting is 5 hours. The raw material used are limestone. Limestone is nothing but calcium oxide. Okay, and another raw material is bauxite. हाई alumina cement में हम क्या यूज कर रहे हैं? Limestone, calcium oxide plus bauxite. This is the composition is there in the high alumina cement, and its setting times are from 4 hours to 5 hours. Okay. Now waterproof cement. What do you mean by waterproof cement? Waterproof cement is nothing but Portland cement with small quantity of air entering materials. entraining materials like oils, fats, fatty acids ground together, means mixed together. Air is entrained in the form of tiny air bubbles which enhances workability and reduces the segregation and bleeding. It increases sulfate water resistance of concrete. So, how it is helping? Increase sulfate water resistance of concrete. That means upon excess of addition of water, that concrete or wall of which is constructed by using the cement won't be weakened, won't be getting any cracks, won't be easily broken, won't be easily collapse. So, that is due to this air bubbles entering into the cavities or void spaces, okay, and that will increase the sulfate water resistance to concrete hardening, okay, that is waterproof cement. Now, third one is white cement. What is white cement? PC is nothing but Portland cement with pure white color produced with white chalk or clay from the iron oxide. Yes, during the last class we were discussing about grey color to the cement is due to the iron oxide. Fe2O3 is the responsible for the grey color to the cement. Now, as iron oxide gives the grey color to the cement, it is therefore necessary for white cement to keep the content of iron oxide as low as possible. Instead of coal, oil fuel is used for burning. Yes, listen carefully. If you increase more and more iron oxide content in the cement, what will happen? Grey color will be becoming white color, and that is not having good adhesive properties of cement. That is a weak cement. That means strength, it is losing the strength. Whenever you are adding the excess of iron oxide, the cement color will be changed into grey to white color, and that cement is weak cement because it is losing the strength. So, that is nothing but white cement which is having poor binding and adhesive properties. Okay. Now, let us stop here, and next class we go for the smart materials. What are the types of smart materials? What is smart materials, and in what way these smart materials are useful for our day to day life? So, we will see in the next coming classes. So, thank you very much.